Okay, good day, students. My name is John Obodo. We'll be looking at trigonometrical functions, that is trigonometry functions in further mathematics. Okay? In our previous class, we have been able to look at trig ratios, the relationship between sine, cosine, and tangent of angles, and also SOHCAHTOA. We are able to look at SOHCAHTOA and the relationship to Pythagoras theorem. Okay, right here we want to go further and see how we can solve problems associated with trig functions, deal with graphs and intrigues, and also solve some algebraic expression in trig form and equations. As we move along, you follow suit. We have to quickly review trig ratios like we treated in the first class. We are able to say that trig ratios are important in dealing with trig functions. Okay, so we consider a right angle triangle. Again, theta. Okay, and here is the hypotenuse. Here is the opposite and the adjacent. Okay, if you recall that we said sine theta is opposite over hypotenuse. Sine theta is opposite of hypotenuse, and cos theta is adjacent over hypotenuse, and tan theta. Tan theta is that is opposite over adjacent. So that leads us to what we call SOHCAHTOA. That is what we call SOHCAHTOA. Okay, we are also trying to explain the relationship between this and the Koshakal, where we talk about the inverse trig ratios, inverse of these trig functions, inverse trig ratios. And we're able to show that 1 over sine theta is cosec theta, and 1 over cos theta is secant, that is sec theta, and 1 over tan theta is equal to cotangent, that is cot theta. So we have Koshakal, that is cosec theta, sec theta, and cot theta. So if you are given an expression, we say if sine theta is 3 over 5, okay, simplify cos theta plus tan theta divided by cot theta. How do we do this? So what you do is you try to see, okay, what is given. Sine theta is 3 over 5, and we ask to simplify this expression. So what you do is that we do a sketch of a right angle triangle to make it easy, and then we have the hypotenuse, the opposite, and the adjacent. Remember your angle, theta. Therefore, what is given is that sine theta is 3 over 5. And 3 over 5 is the same as opposite over hypotenuse. Now, the opposite here is 3, and the hypotenuse is 5. So, therefore, we can say that using Pythagoras theorem, theorem. Remember the Pythagoras theorem. We have the hypotenuse squared equal to the opposite squared plus adjacent squared. Okay? So hypotenuse squared, that is 5 squared, opposite is 3, plus adjacent squared. So when we solve this, we obtain here as 25, here as 9, and we have our a squared. So your simplification, a squared is equal to 25 minus 9. 25 minus 9 is 16. A is root 16. Root 16 is 4. So that means the adjacent is 4. Okay, when we have gotten the adjacent, then we'll be able to get cos theta. What is cos theta? Cos theta is adjacent over hypotenuse. Adjacent is 4. Hypotenuse is 5. Tan theta. Tan theta is opposite over adjacent. Opposite is 3, adjacent is 4. And cot theta, what is cot theta? Cot theta is 1 over tan theta. And 1 over tan theta is 1 over 3 divided by 4. That is 4 over 3, the reciprocal of tan theta. So with this, you can solve the expression cos theta plus tan theta over cot theta. So how do we solve it? Let's solve it in this portion. We have cos theta, which has been given 4 over 5. So you have 4 over 5 plus tan theta, which is given as 3 over 4. We have 3 over 4 divided by cot theta, which is 4 over 3. And you say 4 over 3. So we simplify this. 4 over 5, LCM here is 20. So we have 20. 4, you have 5 here, 4. You have 16 plus 4 here, we have 5, we have 15 divided by 4 over 3. And that is equal to 31 divided by 20, then times 3 over 4. So 31 over 20 times 3 over 4. What does it give? 31 over 20 times 3 over 4. So we have 31 multiplied by 3 is 93. Sorry, that will give us 93. And 20 multiplied by 4 is 80. So we have 93 over 80 as the answer for that expression. Okay, let's go further. Looking at the, want to consider the identity for trig function, or consider the identity for trig function. The basic identity here we'll be looking at is how we can relate sine, cosine, and tangents in a single equation or other parameters. Okay, so when we look at this trig identity, we want to see how we can solve problems that are associated with them and so on and so forth. So let's see some typical relationship between them. Consider a circle. Let's consider a circle of radius r with this point. Okay, we have angle, the radius is r, and probably we have here is 90. We have 90. We have this as an axis. You can call this y-axis and x-axis. We can call this O. We have point O to y and OX. Okay, so here we can say that r squared equal to OY squared plus OX squared. Now, r squared, let's assume that r is 1. R is 1 unit. So if r is 1 unit, so we have 1 squared equal to OY. Our OY in this case can be equal, OY can be equal to sine theta, and OX can be equal to cos theta. So when we substitute, we have sine theta all squared plus cos theta all squared. And that is 1 equal to sine squared theta plus cos squared theta. Okay, so this is one trig identity which has been proved. So that means from what we have here, that sine squared theta plus cos squared theta is equal to 1. Okay, so if we have this, sine squared theta plus cos squared theta is equal to 1, let's see how we can relate to cosec, sec, and cotangent. Now divide equation. Let's call this equation 1. Divide equation 1 by sine squared theta. What do you have? We have sine squared theta divided by sine squared theta plus cos squared theta divided by sine squared theta is equal to 1 over sine squared theta. So when we divide through with that, what you have now is sine squared theta divided by sine squared theta is 1. Add this, we have cos squared theta divided by sine squared theta is 1 over tan squared theta is equal to 1 over sine squared theta is cosec squared theta. That is cosec squared theta. So if that is cosec squared theta, that means we have this as cotangent. We have 1 plus 1 over this is same thing as cotangent. Cot squared theta is equal to cosec squared theta. So we have another trig identity. Okay? That means the first one is 1 equal to sine squared theta plus cos squared theta. The other one is 1 plus cot squared theta is equal to cosec squared theta. Or you can also say that cosec squared theta minus cot squared theta is equal to 1. That is another way of writing it out. So we call this as the second trig identity. Now recall, in previous class that we said that tan theta is equal to sine theta over cos theta. Tan theta is sine theta over cos theta. Okay? And cot theta is 1 over tan theta. So that means that cot theta is same thing as cos theta over sine theta. You should understand all these trig ratios, because once you miss the particular flow of it, you will not be able to get where the root is coming from. So we need to understand where how the equation flows. Okay, so the next one we are trying to see there is a cosec. We said that cosec theta is 1 over sine theta. That is cosec theta. Okay, from the previous class we treated that. Okay, so and the sec theta, secant, is the reciprocal of cos theta. The reciprocal of sec theta. So that is how we got the cochacal that we gave last time. Cochacal. Okay, that will give us the reciprocals of that. So we have this. We have 2 trig identities. Now we want to divide with cos squared theta. Instead of dividing with sine squared theta, we want to divide with cos squared theta and see what happened to the trig identity 1 in equation 1. Okay, as we go along, we see this. So we have sine squared theta plus cos squared theta is equal to 1. Once again, we divide by cos squared theta. If you divide through by cos squared theta, we have sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta is equal to 1 over cos squared theta. Okay? Sine squared theta divided by cos squared theta will give us tan squared theta plus 1. This, we cancel this. Is equal to 1 over cos squared theta is sec squared theta. So we have another trig identity. Okay? That is tan squared theta plus 1 is equal to sec squared theta. So we have been able to prove 3 different identities or 2 different identities from the basic of first trig identity. From the first one, we got 2 others. So with this, you can solve problems associated with trig identity. Let's assume that you are given. Okay? Given that tan theta is equal to 1 over 2. Find sec theta. How do you find sec theta? From this, you can solve this using this identity. So we have a solution to this. We have tan squared theta plus 1 is equal to sec squared theta. Okay, tan squared theta, that means 1 over 2 all squared plus 1 equal to sec squared theta. 1 over 2 all squared, that will give us 1 over 4 plus 1 equal to sec squared theta. And that is the same thing as 4, 1 plus 4. Okay, and that is 1 plus 4, that we arrive, we have this as sec squared theta equal to 5 divided by 4. And sec square or sec theta is square root of 5 over 4. And square root of 5 over 4 is root 5 divided by 2. Okay, so that is the answer for sec theta. You can also solve it using the other approach when we try to solve using a Pythagoras theorem approach. Okay, so with this, we know that we have established a relationship and be able to solve some problem. Now we have an example there. If cos theta is 5 over 13 and the terminal side of the angle lies in the first quadrant, find the values of the other 5 trigonometrical ratio of theta. So we have the solution as stated there. You can do a solution to that, and you solve it by approaching it using the procedures that we have done. Now we see some other problems. How do we solve these other problems? If we want to solve all these problems that we have by simplification and simplifying some certain expression, or you are asked to prove some certain expression, then you can solve. Like we have an expression there. Prove that 1 minus sine theta over 1 plus sine theta is sec theta minus tan theta. Okay, let's see how that can be done. How do we do that? We're asked to prove. Prove that the square root of 1 minus sine theta divided by 1 plus sine theta is equal to, let me take you back there, is equal to sec theta minus tan theta. So it's equal to sec theta minus tan theta. How do you prove this? Okay, so to prove this, we need to simplify the left-hand side. So for us to simplify the left-hand side, we deal with this. So that will give us this, 1 minus sine theta divided by 1 plus sine theta. Okay, all brackets, multiply. We make use of the conjugate as if we are solving sort problem. 1 minus sine theta divided by 1 minus sine theta. Okay, so that will give us what we have next. 1 multiply 1. So you multiply it out. 1 times 1 is 1. Okay, this will give us 1 minus sine theta. Okay, minus sine theta. Then this multiply this will give us plus sine square theta divided by 1. We have 1. Okay, 1 minus sine theta plus sine theta plus sine theta, then minus sine square theta. So if you have this, we have it as simplifying this, we have 1 minus 2 sine theta and plus sine square theta divided by this, we cancel this. So we have 1 minus sine square theta, okay, with the square root. Remember not to relate square root. So we have this now. So how do we deal with this? How do we deal with this? Using what we have done so far. Okay, let's see how we can solve that. So by the time we get there, we have the square of that. Then we can now simplify the other angle. Okay, so what we do next is we can multiply the numerator and denominator and get a value. Okay, you can follow it. We have 1. You can say 1. You can factorize on 1 minus sine theta all squared. You can put this way. All over. This one we turn to cos squared theta. Because note that 1 from this place, 1 minus 2 sine theta plus sine squared theta, okay, is equal to 1 minus sine theta all squared. You can have it that way. And cos squared theta is equal to 1 minus sine squared theta. So by the time I deal with this, I will have square root of 1 minus 2 sine theta plus sine squared theta divided by cos squared theta. So what you do is split the functions into separate entities. So we have 1 divided by cos squared theta minus 2 sine theta over cos squared theta, then plus sine squared theta over cos squared theta. So by the time we have split the identities, what we now do is 1 over cos squared theta is same thing as the square root. You can have it as square root sec squared theta minus, here we have sine over cos here, will give us 2, we have tan theta, then 1 over cos is sec theta, then plus 1. Okay? If we factorize this expression, if we factorize that expression, that is sec squared theta minus 2 tan theta sec theta plus 1, what we are going to have is sec theta. So that will give us square root sec theta minus tan theta all squared by the time we do factorization. So the square root of this is same thing as sec theta minus tan theta, okay, as expected. So that is the answer. Okay, if you go back to previous slide, we still see the expression. So this is what you are asked to prove. So when we prove that, we got the same answer. So you can also simplify and get some other expression depending on what is expected of us, okay? So we look at other terms. When we ask to simplify this, simplify 1 over cos theta plus 1 over sin theta. What will it give? 1 over sin theta plus 1 over cos theta, and this will give us LCM. We have cos theta, sin theta. This we have sin theta plus cos theta. So when we simplify further, what you have is that we can simplify this by rationalizing the expression, and that will give us sin theta plus cos theta divided by cos theta sin theta. So you multiply this by saying sin theta minus cos theta divided by sin theta minus cos theta. So when we do this, this will give us sin squared theta minus cos squared theta, all divided by cos theta sin theta in brackets sin theta minus cos theta. So we have an expression. So we are given this, you can leave it this way as a vulgar form, and you can simplify further and get more elaborate. So if you want to simplify further, we can have 1 over cos theta sin theta, okay? In brackets, you can put in brackets sin theta plus cos theta, close brackets, open another one, sin theta minus cos theta, close brackets, divided by sin theta minus cos theta, okay? So this, we cancel out this. So it returns us back to sin theta plus cos theta, all divided by cos theta sin theta. And if you want to take all to the numerator, we recall that 1 over cos theta is equal to sec theta. And 1 over sin theta is equal to cosec theta. Is equal to cosec theta. So when we substitute, we have sin theta plus cos theta in brackets, open another brackets, sec theta, and another one cosec theta. So we have an expression that we can simplify that to. Okay, so that is for that. So we can move ahead and solve some other similar problems. We can prove this identity. 1 minus 2 sin squared theta equal to 2 cos squared theta minus 1, and cos theta raised to the power of 4 minus sin theta raised to the power of 4 is 1 minus 2 sin squared theta. So you can also simplify these other expressions and see how you can understand some other aspects of a trig function. Now, I want to look at double angles. Double angles in a trig. Okay, when we look at the term double angles, it will lead us to some similar trig functions. When we have something like sin A plus B, cos A plus B, and we have sin A minus B, and cos A minus B. Now, sin A plus B is equal sin A cos B, okay, plus sin A, sin B cos A. So we have this. Sin A plus, cos B, sin B cos A. And this one is cos A, cos B, minus sin A, sin B. And the